Hey all, this is Dr. Vipul Pandey, and I'm going to start this YouTube channel named as Physics for Pedestrian, in which I will be giving lectures on physics based on 10 plus 2 level, and the syllabus of the course will be based on NCERT. In this chapter, we will start with the definition of unit. So let us define unit. Measurement of a physical quantity involves comparison with a certain basic arbitrary chosen internationally accepted reference standard called unit. Like length is there, and for that you have this basic unit which is arbitrarily chosen and internationally accepted. One is meter, another is centimeter, another is decimeter, or like that. Another definition of the unit can be here. It can be said that it is a definite magnitude of a quantity defined and adopted by a convention of law that is used as a standard for measurement of the same kind of quantity. For example of unit, so length is a physical quantity, and the meter is a unit of length that represents a definite predetermined length, right? So, for instance, when referring 10 meter, what is actually meant is 10 times the definite predetermined length called meter, right? Now let us go to the type of unit. So there are two types of units. One is the fundamental or base unit, another is called the derived unit. Now let us define unit. So unit of the fundamental or base quantities are called the fundamental or base unit. The simple example is meter, second, kilogram, etc. Now let us go to the derived units. So what are the derived units? So the unit of all other physical quantities can be expressed as a combination of the base units or fundamental units. Such units obtained for the derived quantities are called derived units. The simple example is meter per second, kilogram meter per second square, etc. Complete system of these units, both the base unit and the derived unit, is known as the system of units. Now there are international system of units. So let us discuss about them. So in earlier times, scientists of different countries were using different system of units for measurement. Now there are three international system system for measurement. What are they? One is CGS or centimeter gram second, and another one is FPS, foot pound and second or BT system, and the third one is the MKS or meter kilogram second system. Presently accepted international system of units is SI or System International des Units in French. So the SI with a standard scheme of symbols, units and abbreviations developed by Bureau International des Poids, it measures in French, or the International Bureau of Weights and Measures BIPM in 1971. It has been recently revised in 2018. It uses decimal system, so the conversion within the system are quite simple and convenient. Now in SI there are 7 base or fundamental units. So what are they? One for the length, the meter, it is represented by small m. For time, it is second, represented by small s, and mass is represented by kilogram, and it in capital K and small g. Electric current in ampere, represented by capital A. Temperature in Kelvin and represented by capital K, and amount of substance in mole, and then luminous intensity in candela or C, capital C and D. Besides 7 base units, there are 2 more units that are defined as one radian, which is defined as the unit of plane angle d theta as the ratio of length of arc ds to the radius r. So d theta is defined as ds divided by r. So as you can see, this is ds and this is d theta and this is r. So the unit is radian. Steradian is the another unit which is a unit of solid angle, and it is defined as a solid angle d omega as the ratio of intercepted area dA of the spherical surface, describing about the apex O at the center to the square of its radius r. So d omega is defined as dA divided by r square. Now let us define SI units. So in the SI units, first we will go to the length, and SI unit of length in meter. So meter is defined as the length of the path traveled by light in vacuum during a time interval of 1 upon 299792458 of a second, where second is defined in terms of the CGM frequency. Now let us define another SI unit, second, which is the unit of time and defined by small s. So it is defined as the time taken by CGM 133 atom to undergo 91,092,631,770 cycles of radiation emitted when transitioning between two energy levels. Now this is the definition of your second. Now let us go to the current and another its unit, which is another SI unit, and it is named as ampere and represented by capital A. So let us go to the definition of the ampere. So an ampere is an electric current equivalent to 10 to the power 19 elementary charges moving every 1.60217634 seconds. Amount of substance, and its SI unit is mole. As it is defined as 1 mole contains exactly 6.02214076 in 10 to the power 23 elementary entities such as atom or molecules. This number is the fixed numerical value of the Avogadro constant Na when expressed in the unit mole inverse, and it's called the Avogadro number. Now let us go to the luminous intensity, and its SI unit is defined is named as candela, which is capital C small d. So it is defined as by taking the fixed numerical value of the luminous efficacy of monochromatic radiation of frequency 540 into 10 to the power 12 hertz and KCD, and to be defined to be 683 when expressed in the units luminosity watt inverse or candela SR watt inverse or candela steradian kilogram inverse meter inverse and second cube. So let us define the SI unit of mass, which is kilogram and represented in kg. So it is defined as by taking the fixed numerical value of the Planck constant H to be 6.62607 into 10 to the power minus 34 when expressed in the unit joule second, which is equals to kilogram meter square second also, and where meter and seconds are defined in terms of velocity of light and frequency multiplied by c, the velocity of. So let us define the SI unit of temperature, which is Kelvin, and represented by capital K. So it is defined as it is defined by taking the fixed numerical value of Boltzmann constant K to be 1.380649 into 10 to the power minus 23 when expressed in the units joule per Kelvin, which is equals to kilogram meter square per second square Kelvin inverse.